Distance between the lens and retina is constant. Only way to focus the object on the retina is to adjust the shape of lens. When we see objects at far away distance, lens of an eye becomes flat and its focal length increases. When we look at nearby objects, length of an eye becomes more rounded and its focal length decreases. This enables us to see objects clearly irrespective of their distance from us. The capacity of lens to change its focal length as and when required is called as power of accommodation. The minimum distance of an object from a normal eye at which it is clearly visible without stress on the eye is called as minimum distance of distinct vision. The position of the object at the distance is called the near point of the eye. For normal human eye, the near point is at 25 cm. The farthest distance of an object from a human eye at which it is clearly visible without stress on the eye is called as farthest distance of distinct vision. The position of the object at the distance is called the far point of the eye. For normal human eye, the far point is at infinity. If person can see nearby objects clearly but cannot see objects at a distance, he is suffering from refraction related defect called myopia or nearsightedness. This can happen due to two reasons. The curvature of the cornea and the eye lens increases. The muscles near the lens cannot relax so that the converging power of the lens remains large. The eyeball elongates so that the distance between the lens and the retina increases. This defect can be corrected by using spectacles with concave lens of proper focal length. This length diverges the incident rays and these diverged rays can be converged by the lens in the eye to form the image of the retina. The focal length of concave lens is negative, so a lens with negative power is required for correcting nearsightedness. The power of the lens is different for different eyes depending on the magnitude of their nearsightedness. If a person cannot see nearby objects but can see far away objects, he is suffering from refraction related defect called farsightedness or hypermetropia. This means near point of the eye is no longer at a distance of 25 cm but shifts little away. In such cases, image of an object forms behind retina. This mainly happens due to two reasons. One, curvature of the cornea and the eye lens decreases so that the converging power of the lens becomes less. Two, due to the flattening of the eyeball, the distance between the lens and retina decreases. This defect can be corrected by using a convex lens with proper focal length. This lens converges the incident rays before they reach the lens. The lens that converges them to form the image on the retina. The focal length of a convex lens is positive, thus the spectacles used to correct farsightedness has positive power. The power of these lenses is different depending on the extent of farsightedness. Most people begin to notice the effects of presbyopia sometime after age of 40, when they start having trouble seeing small print clearly, including text messages on their phone. Generally, the focusing power of the eye lens decreases with age. The muscle near the lens lose their ability to change the focal length of the lens. The near point of the lens shifts farther from the eye. Because of this, old people cannot see nearby objects clearly. Presbyopia is caused by an age-related process. This differs from nearsightedness and farsightedness, which are related to the shape of eyeball and are caused by genetic and environmental factors. Presbyopia generally is believed to stem from a gradual thickening and loss of flexibility of the natural lens inside your eye. Use of bifocal lenses. Sometimes people suffer from nearsightedness as well as farsightedness. In such a case, bifocal lenses are used to correct the defect. In such lenses, the upper part is concave lens and corrects nearsightedness, while the lower part is a convex lens which corrects the farsightedness.